So 5.6, number 61, tangent. So here is our problem. Tangent's our problem. The derivative of what equals tangent? We never learned anything where the derivative was the tangent. So even if I chose this to be u, I'd still end up with tangent u. I still have the same problem. I don't know the derivative of anything that equals tangent. So the secret of this is rewriting. I'm going to rewrite this. I know tangent is sine over cosine. So I'm going to rewrite it like that and see if that helps me out at all. I just realized in the previous problem I was going to try a different technique, and so maybe we'll go back to that one after this. Does this help? Yes, it does. And here is why. You have three choices for u at this point. You could choose this to be u, or that to be u, or x over 2 to be u. Now, the best way to experience this is try all three and see what happens. And you will find out that the best choice for you is cosine of x over 2. Why? Because the derivative of cosine is minus sine. And I have the sine on top, so that works. The problem is if you pick sine to be your u, the derivative of that would be cosine. But the problem is the cosine's in the denominator. Your du cannot be in the denominator. It has to be on top. That's why that doesn't work. So you should pick u to be this. And that's actually a pretty common one where your u is the denominator, because then you'll get an integral of 1 over u, which you should know is ln. So that's why the bottom is a good one to choose. Now, when I take the derivative of this, that has to be box because it's not x. It's a function, so that becomes box. So what's the derivative of cosine of box? It's minus sine of box times the derivative of box, but the derivative of x over 2 is 1/2. And then I'm going to do some manipulation. I'm going to put the 1/2 in front. And then I'm going to put the dx on the right side. So I'm going to pop that over there. And now I have my du. I will do it in gold. And I ask myself, do I have that up here? And I'm like, no, I don't. I'm missing the negative 1/2. Do I have a negative 1/2 there? I don't. But now I do. And I haven't changed anything because that equals 1. And Mrs. Jones in 3rd grade, Ms. Jones? Mrs. Jones, I think it was Ms. Jones, told me that 1 times anything is itself. So that's what I have. So in front, I have a negative 2. And then all of this becomes du. And all of the denominator becomes u. Here is the important part. This is the part that may be confusing, but once you understand and not just memorize, but you understand, things will make sense. This tells me find the net area from 0 to pi over 2. So 0 and pi over 2 are values of x. This here says find the net area. I can't put 0 and pi over 2 because my variable is now u. I need these to be u. Or it wouldn't make sense because it's a different graph and the net area would be different. So I'm changing this. I need a new u. So if you put 0 in for this u, the cosine of 0 is 1. So my new u down here is 1. And if I put pi over 2 divided by 2 is pi over 4. And the cosine of pi over 4 is 1 over radical 2. Now, I'm going to erase this because you normally don't put those there. That's just showing you what's going on. Then, the antiderivative of 1 over u is ln absolute u. You have to know that because you know the derivative of ln is 1 over u. So backwards, the antiderivative of 1 over u is ln absolute u. And I'm going to have 1 and 1 over radical 2. Now, some of you are saying, it's not 1 over radical 2, it's radical 2 over 2. Well, that's the same thing, just a different form. Now, here is where, well, I'll just finish this off, and then I'll tell you where you might go wrong. And it's not necessarily wrong, but I'll tell you mistakes, common mistakes that people make. And I will show you why. So first, I plug in the upper value, and then I plug in the lower value. And I'm not going to put the absolute value there because 1's positive. I don't even need the absolute value in the first one either. Since those are positive, I'm not going to put the absolute values there. I'll do that. Oh, this is going to be crazy. I don't know if you can handle this. This is going to be crazy. ln of 1 is 0 because of the graph of ln that you all know, at 1, it's 0. So that's just 0. Couple of comments. Don't forget the minus sign. There's a minus there, and it should be there. So it should be minus minus. It should be plus, but plus 0, minus 0 doesn't matter. But be careful about that. Be careful about your signs. Now, this answer isn't the answer the book has. The book has, let me see, ln2. You're like, that's different. I messed up. Something's wrong. Well, let me show you why you're not wrong. This is pretty crazy. This is all rules that you learned in Algebra 2 and pre-calculus. The first thing I'm going to do, I'm going to move this to the top and make the exponent change sign. So it's going to be 2 to the negative 1/2, right? You learned you can move that to the top and change the sign and make it a negative exponent. So that's what we did. Then you have another property of logs. You want the next one? The next property of logs says you can p in front of the log. I can take this and make it a power up there, or vice versa. I can switch them back and forth. So I'm going to move that negative 2, I love this problem, up there. That's one of the rules. That can interchange back and forth. So I move it up there. Then I use my properties of exponents. An exponent to an exponent, I multiply those, right? So what is negative 1/2 times negative 2? In my book, that's 1. So the answer is ln of 2. Crazy. Here's the good news. I've never seen an actual AP test where they made you change this into that, because they want to test your calculus and not your algebra. So I've never seen that happen, but it's good to be able to manipulate that and use those properties, because each individual property we use here, you might see on an AP test, but all of those combined to get that, I don't think you'd see that. Okay, now here is trouble sticking points, things that you will do and could get it wrong, especially if it's an FRQ. If this is a multiple choice, you can get away with mistakes. And I'll tell you what I mean by that. But if this were an AP test and this were an FRQ, and you left this as 0 and pi over 2, you didn't change them into u's, you would lose a point because these are not equal. If you don't change those to u's, they are not equal. You are wrong. And they will take a point off for you saying it equals. Okay. Now, here's what some people do. They leave it as x's here. And again, if this is multiple choice, they're not looking at your work. So they're okay. They're not going to find your mistake. But you're making your life much more difficult. And I'll show you why. Then someone will say this. I got this. I'm going to change this u back to an x. I'm going to use that formula there, just like I did on the previous ones. Equals negative 2 ln absolute cosine x over 2 from 0 to pi over 2. That is not wrong. Now it's actually correct because you went back to x, and these are x's. So now if you plug these in, you will get the same answer I got. But let me ask you this. Changing things back to x's, it's an extra step. It's more work to do. It's easy to make a mistake. and it gets uglier. The work that I do now is not going to be as pretty as what I did. So why did we go back to the x in the previous problems? I'll tell you why. In the previous problems, it's an indefinite integral. There's no numbers here. And so since you started with x's, you want your final answer in x's. But in this problem, it's a definite integral, and therefore they want an area, a net area. So they just want a number. So therefore, you don't have to worry about x's and u's and y's and v's. They just want the numerical net area. So you don't have to go back to x to get the net area. Well, we did it. We did all this, leaving everything with u's. And so understand, if this is dx, those are x's. If this is du, those have to be u's, or it'll be wrong. But somebody say, I left them as x's, then I put x here and I got the right answer. Correct. But again, if this were an FRQ, this is not a correct statement. You would lose points because you didn't convert those. You're going to have multiple choice questions sometimes where your answer, they say, if you choose this to be u, what's the equivalent statement? And the equivalent statement, those have to be converted to u's. They can't be x's. So there's some that look like that. So make sure you know why those have to be u's. And I highly recommend never go back to the x. It's so much easier sticking with u. Especially if I gave this to you on a test, you wouldn't try to, you would just do what we did the first time. You wouldn't like, I wonder what the x was, let's put that back in. You wouldn't even think about that. So why are you thinking about it here on this problem? So the moral to this story, and this has an application in real life, and I shared this with you on the video. People go and they date someone and then they break up. And usually they break up because there's something about that person that they really don't like. And then that person's like, please, please give me another chance. I promise I will change. I'll be a new person. And you give them a chance. And at first they're a new person. And then they're back to their old ways, or they're worse. It doesn't get better. 99 times out of 100, or even higher than that, you're going to break up again, and it's going to be uglier, and it's going to be worse. So the moral to the story, don't go back to the X. Stick with you. You're better off with you. You'll be happier with you. Don't go back to the X. All right, that's the moral to that story. Oh man, I recorded all that. That's bonus material.